Okay, in the last class, we discussed to find the solution of second order differential equation with the constant coefficient. So the solution contains two parts. So what is the general form of the second order differential equation is of the form a y double dash plus b y dash plus c y equal to some function of x. Maybe we can call r of x. So this is the general form of second order differential equation with the constant coefficient. Here a, b, c are constant. Now, the solution is of the form is contains two parts. One is the complementary function, another one is particular integral. And then we discussed there are some methods to find the, that is methods means what? First you got to write the auxiliary equation. And then since we will get a second order quadratic polynomial, you will get two roots m1, m2. So if both m1, m2 are real and distinct, then we know what is the solution. If both are same, then we know what is the solution. If both are complex number, we know what is the complementary function. Now, another we discuss. So now we are going to again we can recall how to find the particular integral, okay, of the function. So therefore, the given equation can be written as f of d times y equal to r of x, where this f of d is nothing but the derivative function of derivative, that is a and d square plus bd plus c. Now, therefore, what is solution? Y is the solution. Therefore, y equal to 1 by f of d into r of x. So, this is a solution actually. But we have to find exactly in terms of x. Now, there are cases. Suppose the function r of x is exponential function. Then what is the particular integral? Okay. So, before that, we have to discuss what is the derivative. So, d is nothing but derivative. The inverse of derivative is nothing but integration. Okay. So, the first thing is we have to prove, suppose 1 by d times some function of x. Capital X is nothing but function of x. So, this is same as 1 by d is nothing but inverse of derivative is nothing but integration. So, integral x dx. Okay. Why this is true? So, in 1 by d into x equal to integral x into dx. So, suppose we call this is y. So, let y equal to 1 by d times x. We have to prove y equal to integral x dx. So, now take derivative both sides with respect to y. Therefore, dy by dx. So, dy by dx is but actually d. Applying operate d both sides, we get this. So, do d cancel, we get x. So, x equal to dy by dx. Now, integrate both sides with respect to x. Therefore, this side we get y and this side we get integral x dx. Therefore, what is y? We take 1 by d into x. Therefore, 1 by d into x is nothing but integration x dx. Okay, this is the first result. So, 1 by d is nothing but inverse of the derivative operator is nothing but integration. Now, the second result is, suppose if we take 1 by d minus a, so d is nothing but d by dx into x is nothing but e power minus ax into integral x into e power ax. Okay, maybe you can take plus here and this will be minus into dx. Why this is true? So, we got to prove this. So, if x is any function, then 1 by d minus a into x equal to e power ax into integral x into e power minus ax. Suppose we call 1 by d minus a into x is y, and then we have to prove y is nothing but this. So, let y equal to 1 by d minus a into x. Now, again we have to operate both sides by d minus a. Therefore, we get d minus a into y equal to, we will get d minus a cancel, we get x. So, now apply this y inside. Therefore, d is nothing but derivative. Therefore, we get dy by dx minus ay equal to x. Now, this is a first order differential equation. Now, we know the solution. So, first we have to find the integrating factor for this equation, right? So, integrating factor is e power integral p dx. Here what is p? Minus a. So minus ax, sorry, a dx. So since a is a constant, therefore this is nothing but integral e power minus ax. So this is the integrating factor. So once you know the integrating factor, we can write the solution. Therefore y into integrating factor equal to integral into integrating factor into q. But what is q here? X into dx. Now therefore y into e power minus ax equal to integral x into e power minus ax into dx. But we need y because we take this is y. Therefore multiply e power ax both side, we get y equal to e power ax times integral x into e power minus ax dx. X is any function of x, okay? Capital X is any function of x. But what we take y is nothing but 1 by d minus a times x. So this result is very important result. So 1 by d minus a into x. X is nothing but function, any function of x can be written as e power ax into integral x into e power minus ax dx. So this is the second result. Now we can discuss case by case. So the first case is case 1. Suppose the capital X is exponential function like e power some ax. Okay. So don't confuse with this a and then the coefficient a. Okay. If you're confusing, take the coefficients pq. Okay. Now suppose the right hand side is a function, exponential function, then what is the particular integral? Again, there are two cases. F of a is non-zero. So first case is if, because we know that f of d is the left hand side operator, differential operator. We got to substitute d equal to a. If we get non-zero, then the particular integral is 1 by f of a into e power ax. That is the thing. Now suppose the another case. Suppose f of a is 0. So f of a 0 means what? A is a root of f. That means what? D minus a is a factor of f of d. Then f of d equal to d minus a. Because a is a root, therefore d minus a should be a factor into some function of another operator. Okay, maybe this is square means suppose f is order 2, then we'll get another polynomial. And there are two cases again. If this pi of a is non-zero, okay, there is sub case. Maybe you can write. So that is a is a simple root, not a multiple root. Suppose then d minus a is a factor into pi of d, where pi of a is non-zero. If pi of a is 0, then a is a root with the multiplicity 2. But time being, a is a simple root. Now in this case, then what is the particular integral? So it's nothing but usually 1 by f of d into capital X. But here capital X is nothing but e power ax. But f of d can be factored into d minus a into pi of d into e power ax. So now we can look at this 1 by d minus a into 1 by pi of d into e power ax. Now first you got to operate this. If f of pi of a is non-zero, then we know that this is nothing but 1 by d minus a. First you have to operate this. We know that pi of a is non-zero. Therefore, this value is nothing but 1 by pi of a into e power ax. Since 1 by pi of a is a constant, you can take outside. Therefore, 1 by pi of a into 1 by d minus a, the operator into e power ax. Now we use the result 1 by d minus a into x, any x is nothing but e power ax integral x into e power minus ax dx. So therefore, if you apply here, we get this is equal to 1 by yeah, any doubt?
Sir, is this different from what we learned earlier,
Yeah,
sir?
yeah. So better we use this method.
Okay, sir.
So now by the definition, just now we discussed this is nothing but e power ax into integral what is capital X e power ax, but we have to multiply e power minus ax into dx, right? Because that is a result. If whenever 1 minus a into x is nothing but e power ax into integral x into e power minus x, but in our case x itself is e power ax. So therefore we get this one. So integral e power ax e power minus x, we get e power 0. E power 0 is 1. And if you differentiate dx, we get x. So therefore finally we get x by pi of a into e power ax. This is a particular integral if a is a single root. Suppose a is a repeated roots, then again you got to factor, then you will get. Okay. So otherwise, what is this pi of a? First we have to write what is pi of a. Okay. And we know that pi f of d is d minus a into pi of d. Okay. Now we need pi of a. Now differentiate both sides. So therefore we get f dash of d. You have to apply uv method. First we have to fix d minus a and then differentiate this pi. Okay. So otherwise you can simply so finally what you'll get pi of a is nothing but actually f dash of a. Okay. No. So now we fix this, differentiate pi, we get pi dash of d plus fix pi of d and then differentiate d minus a with respect to d, we get 1. Therefore we get this one. Now substitute d equal to a, we get the left hand side, we get f dash of a. Substitute d equal to a, this term is 0. So total this term is 0, we get pi of a. So therefore this pi of a is nothing but derivative of f at point x. Therefore this is nothing but x by f dash of a into e power ax. This is a particular integral, provided f of a is 0. If f of a is 0, that is a is a simple root, then we have to multiply x and then we have to differentiate f and then you have to substitute. Suppose another case, suppose if f dash of a is 0, in this case the particular integral is you have to multiply again one more x, that is x square, and then you can take the second derivative f double dash of a into e power x. If it is non-zero, if f double dash of a is non-zero, then this is a particular integral. Suppose if f double dash of a is 0, then x cube by f triple dash of a into triple dash of a into e power x. That is a, you have to further you can go. So until you get a non-zero term, you can go it. Okay. So maybe we will discuss one problem related to this. So exercise. To solve the problem d plus 2 times d minus 1 square. Anyway, this is not a second order. Anyway, we can apply this method to any order. So equal to e power minus 2x plus 2 into sin hx. So this is a hyperbolic function sin hx. So there is, we know the formula sin hx equal to e power x minus e power minus x by 2 actually. So therefore everything is nothing but exponential function. So in this case, what is f of d? This factor. So f of d is nothing but d plus 2 into d minus 1 whole square. Therefore now the given equation can be written as this 2 to cancel and the sin hx 2 to cancel. So we get simply they can write f of d into y equal to e power minus 2x plus e power x minus e power minus x. That's it. So you have to find there are three part of in particular. You have to find first you have to take this one and then you got to take this one, and then you got to take this one. So separately you got to find the particular integral. Okay, therefore otherwise simply we can take what is the particular solution, y equal to 1 by f of d times this factor e power minus 2x plus e power x minus e power minus x. Now you can operate this 1 by f of d to the each term, therefore 1 by f of d into e power minus 2x plus 1 by f of d e power minus x plus x minus 1 by f of d e power minus x. Now in the first term you have to substitute f of minus 2. You have to substitute d equal to 2. So but is what is f of d? This one. So substitute d equal to minus 2, we get 0. Okay. So maybe simply we can write. So this is equal to 1 by d plus 2 into d minus 1 square into e power minus 2x plus 1 by d plus 2 into d minus 1 whole square into e power x minus 1 by d plus 2 into d minus 1 whole square into e power minus x. Now first you have to operate this factor. So this can be written as 1 by d plus 2 into 1 by d minus 1 square into e power minus 2x. Now here we get if you substitute d equal to 1, we get this factor is 0. Okay. So what do you have to do? So anyway, first we can interchange it. That is plus 1 by d minus 1 square and then 1 by d plus 2 e power x. Similarly here, anyway this is not a problem, okay, because if substitute d equal to minus 1, so therefore this is minus 1 plus 2 into minus 1 minus 2 square, that is better is simply write 2 square into e power minus x. The last term is not a problem. Now here 1 by d plus 2, if substitute d equal to minus 2 here, therefore minus 2 minus 1 minus 3 is nothing but 1 by 9 e power minus 2x plus 1 by d minus 1 square. Again if substitute d equal to 1, we get 1 by 3 e power x, and this is nothing but 1 by, this is 1, therefore we have 4 e power minus x. Now 1 by 9 is constant, we can take outside. Now if substitute d equal to minus 2, we get 0, therefore we have to multiply 1x, and then we have to differentiate this, okay, that is f by f dash of a. If we differentiate this, we get 1, so therefore simply 1, because if it is any d is there, we have to substitute minus 2, but there is no d if we differentiate, therefore x by 1 into e power minus 2x. Now plus 1 by 3. Now here if you substitute x equal to 1, here you get 0. If you differentiate this, so what is f of d in this case? D minus 1 square. You get substitute x equal to 0. If substitute d equal to 1, you get 0. Therefore, you have to take 1x. But what is f dash of d is 2 times d minus 1. Again, if you substitute d equal to 1, we get 0. Therefore, you go to f double dash of d. So since if you substitute again, we get substitute x equal to 1, you get 0. Therefore, we got to multiply 1 more x. Therefore, we have x square. So, but what is the second derivative? It's just 2. Okay. So now if substitute d equal to any value, you will not get it. Therefore, just x square by 2 into e power x minus 1 by 4 e power minus x. So this is a particular integral. Okay. 1 minute. Okay, so this is a particular. You can take x by 1 is nothing but just x. Okay, so don't worry about suppose the right hand side function is it gives some exponential function, sin x, sin hx or cos hx or tan hx. Simply we can rewrite in terms of the exponential function e power x minus e power minus x by 2. This is sin hx. So cos hx is plus e power x plus e power minus x by 2. This is cos hx. So what is tan hx? You can divide these two. So sin hx by cos hx, therefore e power x minus e power minus x by e power x plus e power minus x. That is a tan hx. So we can rewrite. Okay. Now this is the first case. So if it is the exponential function, we know how to find the particular integral. Now the second case. Suppose the right hand side function is a trigonometry function. Specifically, suppose sin or cos. Case 2, the x, capital X, is sine of some any function or linear function, some ax plus b, or cos of ax plus b, any format. Okay. Now you should know what is the derivative. First of all, what is the d of sine of ax? First, you got to differentiate sine and then differentiate the inside function. So what is the sine? What is the derivative of sine? Is cos of ax plus b, and then what is the derivative of ax plus b is a. Therefore, a into cos. So similarly, you can do the same thing. So second derivation means again you can take a square sine ax plus b. Okay, that operation you should know. Suppose the right hand side function is a trigonometric function like sine of ax plus b or cos of a plus b. Now in that case, what is the particular integral? So again, if f of, you can write in terms of f of d square, the given operator we can look at f of d square. Okay. So if first case, suppose if f of minus a square, you can take the coefficient of x. Okay. You have to look at what is f of minus a square. That is, you got to substitute d square equal to minus a square in the f of d. Suppose if it is non-zero, then the particular integral is 1 by f of minus a square times sine of this one. If it is sine, you can take sine of ax plus b. Suppose your right hand function is cos, you can take cos. Okay. So therefore, better I remove this one. So similarly, we can do for cos. So the first case, if f of minus a square non-zero, then this is a particular integral. Suppose f of a square is 0, f of minus a square is 0. So the next case is if f of minus a square is 0. So in that case, maybe I can directly write. You can again you can multiply by x and then differentiate f. After that, you got to substitute minus a square. Okay. So in that case, what is a particular integral? If suppose it contains, so minus a square is a root. That means what? It contains the factor d square plus a square. Okay, if you replace d square by minus a square, we get 0, right? Suppose the minus a square is a simple root. That means it contains only this factor. Then the particular integral is nothing but x by, you have to differentiate f and then you have to substitute minus a square into, you have to differentiate, okay, anyway, sine means sine of ax plus b, provided again for this case f dash of minus a square is non-zero. Suppose again subcase, suppose f dash of minus a square is 0, then x square by, you're going to take the second derivative and then substitute minus a square, d square by minus a square sine of ax plus b. Again in this case, we have to assume that f double dash of minus a square is non-zero. Suppose f double dash of a square is 0, then x cube by f triple dash of minus a square sine of ax plus b. Similarly for cos. Okay. Now we solve some problem later this. So look like this is the L-Hospital rule. Okay, just you have to differentiate, not L-Hospital rule, but you have to differentiate. If it is 0, we have to differentiate the function, and then you have to substitute minus a square. Now solve or find the particular integral of the equation d cube plus 1 into y equal to cos of 2x minus 1. So here a is 2, b is 1. Now, so what is f of d? f of d is nothing but d cube plus 1. So d cube 1 can be written as d into d square, but we are going to substitute d square equal to minus 4, right? So that's why we can factor it. So here a is 2, therefore what is minus a square is minus 4. We have to substitute, therefore what is f of minus 4 is nothing but minus 4d plus 1, right? Now what is the particular integral? Usually the particular integral is 1 by f of d into the function. So the function is cos of 2x minus 1. Now finally we get minus 4d. After substitution we get minus 4d into cos of 2x minus 1. Now we have to cancel this d. Therefore we have to multiply and divided by the conjugate, that is 4d minus 1 by 4d minus 1. We get a 4d plus 1 into 4d minus 1. You have to multiply and divide by the same number times cos of 2x minus 1. Now the denominator is of the form a plus b into a minus b, therefore is a square minus b square, therefore minus 4d minus 1 by a square, that is 16d square, minus b square, that is minus 1, cos of 2x minus 1. Now substitute d square by minus 4 again. So we get minus 4 into, so we get a minus 4 into 16, that is 64, minus 64. Minus 64 minus 1 is minus 65. In the denominator we have minus 65. In the numerator we have minus 4d minus 1 times cos of 2x minus 1. Now apply cos of, we have to cancel this numerator d. So therefore minus 1 by 16 is a constant. We get, you can take, even if you take minus outside, therefore minus minus plus. Therefore 4 times derivative of cos. What is the derivative of cos is minus sine 2x minus 1. And then if you differentiate this 2x minus 1, you get 2 plus 1 into cos. Therefore just cos of 2x minus 1. So that's it. Therefore totally we get 2 times 4 is 8. Therefore 1 by 65. Maybe we can take this cos of 2x minus 1 first, minus 8 times sine of 2x minus 1. So this particular integral. Okay. Any doubt in this? Similarly, suppose instead of sin x, suppose sine 2x. Again, sine 2x is nothing but 2x plus 0. So we can apply any either sine or cos trigonometric function in the right hand side. Now the third case, case 3. So the right hand side function capital X is x power something. So if the capital X is x power some m, it's a polynomial in m, just x power m. In that case, what is the particular integral? So therefore the particular integral is nothing but 1 by f of d. So what is 1 by f of d into this factor x power m. Okay. So we can take this f of d, the numerator, we get f of d inverse x power m. Now we can expand this f of d using the formula. So we'll get and then you got to multiply x power m to the each term and then differentiate, you will get a answer. So for example, we solve some problem related to this. Just we have to take this denominator factor to the numerator and then expand that f of d. So example, exercise. So solve d square, find the particular integral of d square plus d equal to x square plus some 2x. If you want, you can take 4. So this contains 3 factors. So what is f of d here? F of d is this d square plus d. Therefore the particular integral is 1 by f of d into this factor x square plus 2x plus 4. But 4 can be written as 4 into e power 0 x, because anything power 0 is 1. So this 4 into 1 can be written as e power 0 times x. Now therefore we can simplify for each term. We have 1 by f of d. So what is f of d here? Maybe d square. Okay. So maybe we can take d outside. Therefore 1 by d into d plus 1 into x square plus 1 by d into d plus 1 into 2x plus 1 by, we can take directly, we can write d square plus d into e 4 times e power 0 x. Because in this case you can directly substitute d equal to 0. If d equal to 0, we get 0. Therefore we got to differentiate. Okay. So anyway, in this case, first you got to keep this 1 by t and then operate this one. So you can take this 1 plus d outside, we get a numerator, we get 1 plus d whole inverse in the numerator. Okay, first you got to apply operate only the 1 plus d, this into x square. After that you got to operate 1 by d. So similarly here, first you got to operate this one. Therefore you can take the numerator, we get 1 plus d inverse into 2x. So here 4 is a constant anyway. Now if you substitute x equal to d equal to 0, we get 0. Therefore we get put 1x. And if you differentiate, we get 2d plus 1. Now if you substitute 0, we get 1. Therefore just 4x into e power 0x. So e power 0x is nothing but just 1. Therefore we have 4x, the last term. So this actually, sorry, this is 1 minus 1. Now this is 1 plus x whole inverse. So therefore this is nothing but 1 by d. So alternative plus minus, therefore 1 minus d plus d square minus and so on into x square. Again 1 by d times, if we expand this, again 1 minus d plus d square minus d cube and so on into 2x plus 4x. Okay. So now we know that the derivative is second derivative. So first derivative of x square is 2x. Second derivative of x square is 2. But if you take third derivative of x square is 0. Therefore, better we consider only the third derivative. So therefore, it's nothing but 1 by d, 1 into x square is x square minus derivative, first derivative is 2x, second derivative is plus 2. Okay, that's it. Plus 1 by d, here multiply 2x inside, therefore 2x. Now first derivative is 1, therefore just minus 2, second derivative is 0, plus 4x. Now 1 by d is nothing but, I already said that, integration. So what is the integration of x square? Is x cube by 3 minus integration of x is x square by 2, 2 cancel, we get just x square. And then integration of 2 is 2x plus, again 1 by d is again this is x square by 2, 2 cancel, we get x square, and then minus 2x plus 4x. That's it. You can simplify it. So therefore x cube by 3, x square cancel, 2x cancel, we get 4x. Okay. So this is a x cube by 3 plus 4x, the particular integral of this one. Now next case, suppose we have function of x and then exponential function. Suppose the right hand side function is a product of exponential function with some other function. In that case, what is a particular integral? Case 4, if the capital X, the right hand side function x, is some exponential function e power ax into some function b, where v is a function of x. Capital V is some function, is a function of x. Okay. Now in this case, how to find the solution of this equation? Okay. So you can take what is the particular integral? Y is nothing but, again y is nothing but 1 by f of d into capital X, but it's nothing but f of d capital X nothing but e power ax times v. So if you take this e power ex outside, if you take e power eax outside, we have to replace d by d plus a. Therefore, we get f of d plus a. Okay, so you have to replace d by d plus a if you take e power ax outside. Okay, now into v. That's it. So depending upon v, you can simplify it. For example, so this v is a function of x means what? This v may be sin x, this v may be cos x, or this v may be x power n or anything. So, so any possible function. Okay. So then you can easily find the integrating factor. So just if you take e power ax outside, so just you got to replace d by d plus a. Okay. Now, next case, maybe we will discuss some example. If we take a example for this one exercise, solve or find the particular integral of the equation d square minus 2d plus 4 times y equal to e power x into cos x. Okay, so we know what is f of d is nothing but this. Therefore, the particular integral is 1 by f of d into e power x into cos x. If you take e power x outside from the operator f of d, then we have f of d plus 1 into cos x. So just to replace d by d plus 1, we get 1 by in the f of d plus 1 square minus 2 times d plus 1 plus 4 into cos x. Now if you simplify this, you get is equal to e power x into 1 by d square plus 2d plus 1 minus 2d minus 2 plus 4 times cos of x. So don't write cos x here because you have to operate this function. Therefore, you have to write cos x after this operator. Now we can cancel this 2d. Therefore, this is actually 5 minus 2 is 3. Therefore, e power x into 1 by d square plus 3 into cos x. But here what is a is 1. You have to substitute d square by minus 1. Therefore, minus 1 plus 3 is 2. Therefore, the particular integral is e power x by 2 into cos x. This is a particular integral. Okay. So, any doubt up to now? So, therefore, if you have function, the right hand side function is a multiple of exponential function. First, you got to take exponential function outside. Therefore, replace d by d plus a. Suppose you are taking e power minus ax outside, then replace d by d minus a. Okay, that's it. That's the only idea. Now, next case is, suppose x is any function of x. Okay. If x, so the fifth case, case 5. Is the right hand side of x is any function of x, general function. So if capital X is any other function, any other function of x. Okay. In that case, what is the particular integral? So we have to factor this f of d and then you have to apply. Okay. So we have to find the root because already we know that given any f of d, we can easily factor it. So once you factor it, you can apply the partial fraction. So suppose the particular integral is, we know that 1 by f of d into capital X. Suppose we can factor this f of d. So namely we can say some d minus m1 into d minus m2. Suppose we have m1, m2 are roots of this one. So m minus some d k into capital X. Now you got to apply partial fraction for this factor. So we'll get 1 by something, we get some constant, so otherwise some a1 by d minus m1 plus a2 by d minus m2 and so on. If I apply the partial fraction to this, we can rewrite this. If it is, suppose we can factor this f of d, then we can apply the partial fraction, we get write this one into x. And then you have to multiply this x to the each term, and then we get 1 by d minus m1 into x. We know how to solve it. Okay. So for any doubt? Okay, maybe we solve some problem. Anyway, if contains all type of problems, you can easily solve it. So whenever the right hand side function contains the exponential function, we can easily find the particular integral. You can take outside e power x and then replace d by d plus a. Suppose we have the right hand function is some x times sin x or x times cos x. So we have to do some simple thing there. So maybe I will solve that problem. Another possible function. Suppose the right hand is function product of x into sin. Then how to find the solution? In that case, we have to use the Euler's theorem. Suppose solve this d square minus 1 into y equal to x into sin 3x plus cos x. So find the particular integral. So therefore particular integral y is nothing but 1 by d square minus 1 times this capital X is nothing but x into sin 3x plus cos x. So therefore you can separate it. We get 1 by d square minus 1 into x into sin 3x plus 1 by d square minus 1 into cos x. So d square plus 1 is d square minus 1 is d plus 1 into d minus 1, right? So we can factor it again. So simply I can write here. So d plus 1. Yeah, okay, anyway, first we can write d minus 1. Okay, this directly if you substitute x equal to 1, you get 0. Okay. And then you have to differentiate. Okay, anyway. So this is equal to 1 by, so we will come later to this first factor. So 1 by d square minus 1 into x into sin x. If substitute d square equal to minus 1, okay, directly we can substitute, right? So it's not 0. So if substitute d square equal to minus 1, so we get minus 1 minus 2. Therefore, we get 1 by 2 minus 1 by 2 cos x is never 0. Therefore, minus 1 by 2 cos x. Okay. Now, the only thing is we have to find this factor. Maybe I write separately. So, we have to find 1 by d square minus 1 into x sin x. But we know that the exponential e power ix is by Euler's theorem cos x plus I sin x. If suppose the function contains e power ix, then you can easily solve that value, right? So, but we need sin x. Therefore, you have to take the imaginary part. The imaginary part of this e power ix is nothing but sin x. The real part of the e power ix is cos x. Okay. Now, I can write this is equal to 1 by d square minus 1 x into, instead of sin x, I am going to write imaginary part of e power ix. Since x is just a number, real number, so therefore we can take this imaginary outside. Totally can take the function and then we take the imaginary. So 1 by d square minus 1 x into e power ix. Now you can take this e power x ix outside. Therefore, you have to replace d by d plus I, because here I is the constant. So imaginary part of 1 by can replace. So you can take e power ix outside. Therefore, replace d by d plus I. Therefore, d plus I square minus 1 into x. Now, what is d plus I square? D square plus 2id plus I square, that is minus 1. So already we have minus 1, here minus 1, therefore minus 2. So therefore this is equal to imaginary part of e power ix times 1 by d square plus 2id minus 2 into x. Now you can take 2 outside, we need 1 plus something. Okay, so therefore this is equal to imaginary part of e power ix 1 by, if you take 2 outside, or if you want to take a minus 2 outside, we get 1 minus d square, or if I take 2id minus of 2id plus d square whole divided by 2 into x. Now this is 1 minus x something, therefore you can take the numerator, we get 1 minus x whole power this thing. Therefore it will take some little time. So e power ix into, anyway you can take minus 2 here. Now we get 1 minus 2id plus d square by 2 whole inverse into x. So this is 1 minus x whole power, therefore everything is plus. But if you take the first derivative of x, you get 1. The second derivative is always 0. So no need to write all the derivatives. So only first derivative is enough. So imaginary part of minus e power ix by 2, we get 1 plus this thing. 1 plus 2id plus d square by 2. The next term should be square. So therefore, it automatically contains the derivative d square. Anyway, no need this one, because if I apply x, it will 0. Now, if I apply x inside, so each term we get the imaginary part of. So the imaginary part is very important. Finally, you got to take the imaginary part. So minus e power ix by 2, x into 1 is x, and this 2 to cancel, I times derivative of x is 1, therefore just I. Okay, and then derivative of d square into x is 0, therefore only we get this one. Now this we can take this minus 1 by 2 outside, because just a real number. So imaginary part of, what is e power ix now? Cos x plus I sin x into the another complex number we have, x plus I. Now multiply this number and then take only the imaginary part. So therefore you will get imaginary. If you multiply cos x into I, we get imaginary I, therefore we have cos x. And if you multiply sin x to this, we get x times, so plus x times sin x. All others are real part, therefore this is a particular integral. Okay, any doubt in this? So suppose whenever the right hand side function contains x into sin or x into cos, you have to convert into e power ix, and then you have to find the imaginary part or real part depending upon sin or cos. If it is cos, you can take the real part. If it is sin, you can take the imaginary part. So this is a main idea to this. Okay. Okay. So far we discussed 5 cases. So the next class maybe we'll discuss a method of variation of parameters. That is, we have to find the solution of variable coefficient, and then we will discuss Euler equation. Okay. Now I stop the class.